All right, so let's talk about a couple of the policies that we mentioned earlier, right? So the way the transaction is going to deal with all these threads running around is that they're going to provide an API to the console or the API to Java or whoever is accessing the database, whoever has a live connection to the database to what we call it demarcate the transactions, right? It's going to be able to tell the database that says, hey, I'm about to do an operation. I want the transaction to start now. Okay, and so we send a command to the database, and the database says, okay, and it'll also, depending on the type of policy that we have configured, the transaction will be either very laxed or it will be very aggressive at how it's going to lock the various records and tables. And the way it's going to do it is through the use of locks, right, or semaphores, right? These are techniques that are very common even in operating systems and whenever you have a multi-threaded environment that you have multiple processes running at the same time and that they're sharing some common resource. It's very common to use these techniques of locks and semaphores, right, to tag or to demarcate a certain resource as being busy, right, or that somebody is using it and no one else should touch it, right, and so transactions, as we'll see soon, right, have different levels of isolations, right, that can be enforced. But then they provide these APIs to Java or Node.js or in whatever language you choose, or .NET, right, to start, right, a transaction, and so meaning the thread is establishes an intent, right, that it would like exclusive access to a particular row or particular table for a particular operation. And then the database will enforce this isolation. The thread will execute all the different operations, and once it's done executing those operations, it can then issue a commit and say, "Hey, I'm done." Right? All those operations that I've made, I inserted over here, or I updated over there, I deleted, I selected, I did several operations. I now want to those temporary changes. I want to make them permanent, and then we do the commit. Now, depending on the isolation level, and depending on whether you're reading, writing, and whatnot, other threads could be allowed to access the data or not, right? Depending on how we configure it. If it's a read operation, then the policy might say that, hey, it doesn't matter that we're in a transaction. Other folks can come and read, depending on the policy. Or if we have a very aggressive policy, we might say, no, even if I'm reading, right, I want exclusive access to this row or this table, right? And all the other threads are going to have to wait until I'm done, right? And so yeah, we can establish what kind of level of isolation we want. Now, JDBC we've used before, and we've used some really simple transaction management. By default, JDBC uses a policy called autocommit, and what it means is that every single operation that we do, whether we do a select, an insert, an update, a delete, it automatically commits. Right? Each operation is its own transaction, right? That means that if we're going to insert something, then that means that a transaction is begun, but right before we're inserting, we do the insert, and then we commit and we're done, right? That means that during that time, we might have exclusive access to that table, and that might be okay or not. Usually, more sophisticated operations where we need to do several updates here and there, autocommit is not enough. and we need to be a little more nuanced, and we need to be a little more specific on what kind of isolation we want. So we'll see how to configure that. So here are a couple of transaction isolation levels that we can configure. These different types of isolation levels, they solve different problems, and we'll see later on what are the type of problems. So there are 3, 4, or 5 different types of problems that we can run into depending on whether we allow multiple threads to access the data at the same time or not. And so these different problems can be treated with different levels of aggressive transaction isolation, right? The different types of isolations are listed here down below, right? There's read uncommitted, there's read committed, repeatable reads, and serializable. And these are progressively more aggressive isolation levels. There is the least aggressive is the read uncommitted, meaning you have all the threads, and some threads are writing, some threads are reading, and if I'm going to allow reading of data that hasn't been yet committed, right? That's again, I'm allowing folks to read data that might be stale, right? That by the time you read it, and later on, that data that you took away and you read might be stale, might not be actually the most up-to-date information. So you might be making decisions that might be wrong based on stale data. So read uncommitted is the least isolation, meaning everything goes. Everybody can read and write whenever they want, right? We're not stopping anybody, and it's obviously it's the most dangerous, and it's the one that allows most inconsistency. But it might be okay for your particular application, right? You might have other mechanisms that enforce isolation other than the database, right? There might be social mechanisms for isolation, no pun intended, where we might say, hey, I'm going to be reading from this document here. Please don't touch it. Don't make any edits, right? Because I'm gonna be reading it, right? And that might be enough, right? That we socially agree that don't change the data while I'm reading it right now, and that might be enough, and to avoid any inconsistency. Now, the most aggressive isolation is serializable. So this one is provides the most isolation between the threads, and say, hey, when I'm if I'm going to access this information, everybody else is blocked. Okay, don't come in here. If you try to read or write or whatnot, you're going to be put in a queue, and first come first serve, right? And first I come in, I do my operation, and when I'm done, I release the locks, and then the next one in the queue comes in, and then they're allowed to go in, right? So those are the most aggressive mechanism, and this one solves all the problems, right? All the inconsistency. You're avoiding all inconsistency. Things happen in the order in which they, in a particular order, right? Now you might say, well, why don't we always do serializable? What's the problem, right? Well, the problem is that we made all this effort at having multi-threading, right? Because we wanted to have the most efficient use of resources, right? Is that we have all these threads running around everywhere, right? But now, if you start serializing data access, we're kind of going against the original architecture of having multiple threads trying to access information, right? That they want to run around independently of each other with their own timeshare and whatnot. And so if you go serializable, then you're kind of going against that architecture of having multiple threads running at the same time. If they're going to start queuing up, waiting for resources to be available, you're basically going against the efficient use of resources, right? So there typically there is a There isn't all this all or nothing, right? The nothing is the read uncommitted. Everybody goes, doesn't matter who, nobody's waiting on anything, and the other extreme is serializable. But there's other in betweens, right? There's a gray area where we might allow certain things to happen, and that's the repeatable reads and read committed, right? And so, and depending on these isolation levels, we'll be solving different problems. So let's take a look at the different problems, right, that we might encounter. So the three main problems that we will encounter is these are categorized here. One of them is reading uncommitted data, that's sometimes also referred to as dirty reads, meaning, here comes a thread, and they're starting to read, do a select command, and the reading data, and data that might be stale, that somebody else might be writing, and so we don't really know what the end result will be. So I'm doing a dirty read. So I might be making erroneous decisions on data that might be stale. The other one is unexpected changes on existing records or several records, right? It might be that I do a select statement, that the result set comes back with 10 rows, but by the time I get the 10 rows, there was actually somebody either inserted another row or deleted a row that for some reason it did not result in my select statement. My select statement came back with 10 rows, but in the meantime, while those rows were coming in, somebody was inserting or removing rows that might have affected my result set. That instead of 10 rows, it really should have been 11 rows or 9 rows, right? And so now I have a result set in my cache, in my memory, that really doesn't reflect the reality that is already stored in the database. So these are all different problems. They have specific names, dirty reads, phantom reads, non-repeatable reads. So we'll take a look at each one of them and see how we can solve them different using the different isolation layers.